Using a 10/2 with ground cable as a substitute for a 10/3 cable when connecting a clothes dryer is not recommended. There are several important reasons why the correct cable type should always be used. Firstly, safety is a critical consideration. A 10/3 cable is specifically designed to carry 3 conductors: a hot wire, a neutral wire, and a ground wire. If a 10/2 with ground cable is used instead, the ground wire would have to be shared between the white and red wires. This can create potential electrical hazards. Secondly, ampacity, which refers to the maximum amount of current a cable can safely carry, is another factor. A 10/3 cable is typically rated to handle a higher ampacity compared to a 10/2 with ground cable. Using an undersized cable like the 10/2 could lead to an overload situation, posing a significant fire hazard. Thirdly, compliance with building codes is essential. Electrical codes generally mandate the use of a 10/3 cable for connecting clothes dryers. Substituting a 10/2 with ground cable would be a direct violation of these codes. This could lead to a failed electrical inspection and potentially increase the risk of a fire. To ensure safety, compliance with regulations, and proper operation of the clothes dryer, it is crucial to use the correct cable type, which is the 10/3 cable. Understanding the function of each wire within the cable is important. In a standard 10/3 cable setup, the black wire serves as the hot wire, carrying the electrical current from the breaker to the appliance. The white wire functions as the neutral wire, providing a return path for the current back to the electrical panel. The ground wire, which is typically bare copper or green insulated, provides a safety path for stray electrical current in the event of a fault, helping to prevent electrical shock. If a 10/2 cable with ground were improperly used, the intended functions of these wires would be compromised. The white wire, if repurposed, might not be able to adequately handle the neutral load, and the shared ground could become overloaded in a fault condition, negating its safety function. Always consult with a qualified electrician for any electrical work to ensure it is done safely and in compliance with local electrical codes. They can provide guidance on the correct wiring methods and materials for specific applications, ensuring the safety and integrity of the electrical system. Furthermore, remember that electrical codes are in place to protect people and property from electrical hazards. These codes are developed and updated regularly by organizations such as the National Electrical Code, or NEC, which is a widely adopted standard for safe electrical installations. Adhering to these codes is not only a legal requirement in many jurisdictions, but also a responsible practice that helps prevent electrical fires, shocks, and other dangerous situations. If unsure about any aspect of electrical work, always seek professional help. Attempting electrical work without proper knowledge and experience can be extremely dangerous and can lead to serious injury or even death. Licensed electricians have the training, experience, and tools necessary to perform electrical work safely and correctly. Remember to always turn off the power at the breaker before working on any electrical circuits. This will help to prevent accidental electrical shock. Double check that the power is off using a non-contact voltage tester before touching any wires or electrical components. Also, be sure to use the correct tools for the job. Using the wrong tools can damage electrical equipment and increase the risk of electrical shock. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves, to protect yourself from potential hazards. When connecting wires, make sure the connections are tight and secure. Loose connections can cause arcing and overheating, which can lead to fires. Use wire connectors that are appropriate for the size and type of wire being used. If unsure about how to make a proper wire connection, consult with a qualified electrician. Finally, always test the circuit after completing the electrical work to ensure it is working properly and safely. Use a multimeter to check for proper voltage and continuity. If there are any problems, such as loose connections, incorrect wiring, or damaged components, correct them immediately before using the circuit. Remember, electrical safety is paramount. Taking the necessary precautions and following best practices can help prevent electrical accidents and ensure the safety of everyone in the home. Ignoring these precautions can have severe consequences, including injury, death, and property damage. Therefore, it is always better to err on the side of caution and seek professional help when needed. In summary, the substitution of a 10/2 cable with ground for a 10/3 cable in a clothes dryer installation is not advisable due to safety concerns, ampacity limitations, and built-in code violations. Always use the correct cable type and consult with a qualified electrician to ensure a safe and code-compliant installation. When dealing with electrical work, it's also important to understand the basics of electrical circuits. An electrical circuit is a closed loop that allows electrical current to flow from a power source to an electrical device or appliance and back to the power source. For a circuit to function properly, it must have a complete path for the current to flow. This path consists of conductors, such as wires, that carry the current from the power source to the device and back. In a typical household electrical system, the power source is the electrical panel which receives power from the utility company. The electrical panel contains circuit breakers, which are safety devices that protect the circuits from overloads and short circuits. When the current in a circuit exceeds the capacity of the circuit breaker, the breaker trips, interrupting the flow of current and preventing damage to the wiring and appliances. Understanding the different types of circuits is also important. There are two main types of circuits: series circuits and parallel circuits. In a series circuit, the components are connected in a single path, so the current flows through each component in turn. If one component in a series circuit fails, the entire circuit is broken and no current flows. In a parallel circuit, the components are connected in multiple paths, so the current can flow through each component independently. If one component in a parallel circuit fails, the other components will continue to function normally. Most household electrical circuits are parallel circuits, which allows multiple appliances and devices to be connected to the same circuit without affecting each other. When working with electrical circuits, it's important to understand the relationship between voltage, current, and resistance. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms. The relationship between voltage, current, and resistance is described by Ohm's law, which states that voltage is equal to current multiplied by resistance, or volts equals amps times ohms. Understanding Ohm's law can help troubleshoot electrical problems and ensure that circuits are operating within safe limits. When selecting wires for electrical circuits, it's important to choose the correct wire size for the amount of current the circuit will carry. Wire size is measured in American wire gauge, or AWG. The lower the AWG number, the larger the wire size. Larger wires can carry more current than smaller wires without overheating. Electrical codes specify the minimum wire size that can be used for different types of circuits. For example, a 15 amp circuit typically requires 14 AWG wire, while a 20 amp circuit typically requires 12 AWG wire. Using undersized wires can create a fire hazard. When connecting wires to electrical devices, it's important to use the correct wiring methods. Electrical codes specify how wires should be connected to terminals, switches, receptacles, and other electrical devices. Wires should be securely fastened to the terminals to ensure a good electrical connection. Loose connections can cause arcing and overheating, which can lead to fires. It's also important to use the correct type of wire connectors for the wires being connected. Wire connectors are used to join 2 or more wires together. There are many different types of wire connectors available, each designed for specific applications. Using the wrong type of wire connector can create a hazardous situation. In addition to understanding the basics of electrical circuits and wiring, it's also important to be aware of common electrical hazards. Electrical shock is one of the most common electrical hazards. Electrical shock occurs when a person comes into contact with a live electrical circuit. The severity of an electrical shock depends on the amount of current that flows through the body and the path the current takes. Electrical shock can cause burns, muscle contractions, heart problems, and even death. Electrical fires are another common electrical hazard. Electrical fires can be caused by overloaded circuits, short circuits, loose connections, and damaged wiring. Electrical fires can spread quickly and cause significant damage to property. To prevent electrical hazards, it's important to follow safe electrical practices. Always turn off the power at the breaker before working on any electrical circuits. Use caution when working near water or other conductive materials. Never overload electrical circuits. Replace damaged wiring and electrical components promptly. Have a qualified electrician inspect the electrical system periodically to ensure it is in good condition. In conclusion, electrical work can be dangerous if not performed properly. It's important to have a basic understanding of electrical circuits, wiring methods, and common electrical hazards. Always follow safe electrical practices and seek professional help when needed. By taking the necessary precautions, one can help prevent electrical accidents and ensure the safety of themselves and others. The importance of using the correct tools for electrical work cannot be overstated. Using the wrong tools can not only damage electrical components but also significantly increase the risk of electrical shock and injury. For example, when stripping insulation from wires, it's essential to use wire strippers specifically designed for that purpose. Using a knife or other sharp object to strip insulation can easily nick or cut the wire, which can weaken it and create a point of failure. Wire strippers, on the other hand, are designed to remove the insulation without damaging the wire. When working with electrical panels or circuit breakers, it's important to use insulated tools. Insulated tools have a non-conductive coating that protects the user from electrical shock. Using non-insulated tools in these situations can be extremely dangerous. When testing electrical circuits, it's important to use a multimeter that is properly rated for the voltage and current being measured. Using a multimeter that is not properly rated can damage the meter and create a safety hazard. It's also important to wear appropriate personal protective equipment, or PPE, when working with electrical equipment. PPE includes safety glasses, insulated gloves, and appropriate clothing. Safety glasses protect the eyes from flying debris, insulated gloves protect the hands from electrical shock, and appropriate clothing protects the body from burns and other injuries. Electrical codes are constantly evolving to reflect new technologies and best practices. It's important to stay up to date on the latest electrical codes to ensure that electrical work is performed safely and in compliance with regulations. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The NEC is updated every 3 years to reflect changes in technology and best practices. State and local jurisdictions may also have their own electrical codes, which may be based on the NEC or may have their own unique requirements. It's important to be familiar with the electrical codes that are in effect in the area where work is being performed. Electrical inspections are an important part of the electrical safety process. Electrical inspections are conducted by qualified inspectors to ensure that electrical work is performed in compliance with electrical codes. Electrical inspections can help identify potential hazards and prevent electrical accidents. Many jurisdictions require electrical inspections for new construction, renovations, and other electrical work. It's important to schedule an electrical inspection before energizing any new electrical circuits. Electrical permits are often required for electrical work. Electrical permits are issued by local jurisdictions to ensure that electrical work is performed in compliance with electrical codes. Obtaining an electrical permit before starting electrical work is important. It ensures that the work will be inspected by a qualified inspector and that any potential hazards will be identified and corrected. In addition to following safe electrical practices, it's also important to be aware of the signs of electrical problems. Some common signs of electrical problems include flickering lights, frequently tripping circuit breakers, and outlets or switches that are hot to the touch. If any of these signs are noticed, it's important to have the electrical system inspected by a qualified electrician. Ignoring electrical problems can lead to serious consequences, including electrical fires and electrical shock. Education and training are essential for electrical safety. If interested in learning more about electrical safety, consider taking an electrical safety course. There are many different types of electrical safety courses available, ranging from basic courses for homeowners to advanced courses for electricians. Taking an electrical safety course can help increase the knowledge and skills needed to work with electricity safely. Remember, electrical safety is everyone's responsibility. By following safe electrical practices, one can help prevent electrical accidents and ensure the safety of themselves and others. Also remember, never work on a live circuit. Always make sure you know what you are doing, and if you don't know, call a licensed electrician. Do not risk your life. A licensed electrician is trained to perform these types of services and ensure that the work is completed safely and correctly. Always remember to prioritize safety when dealing with electrical systems. Taking the time to learn about electrical safety and following safe practices can help prevent accidents and ensure the well-being of everyone. It is also important to recognize the limitations of one's own knowledge and skills. If unsure about how to perform a particular electrical task safely, it is always best to seek the assistance of a qualified professional.